In this video, we are going to try to build a basic understanding of force, types of forces, and mass, and how mass affects the motion of an object which is under the influence of a certain force, and Newton's first law of motion, and finally the inertial frames. So, to build that basic knowledge, basic understanding on force, let's consider those three examples. In the first example, a guy is trying to push a crate, a box, let's say, a box. And in the second one, a goalkeeper is kicking a ball into air. And in the third one, iron bar is drawn by a permanent magnet. When you analyze those three examples, you will see a difference between those. For example, in the first two examples, the force is conducted from one system to another via direct contact here. Similarly, in the second example, again the force is conducted from one system to another via direct contact because of the very moment of kick, the ball and the foot of the goalkeeper was in contact. So the force is acted from the foot to the ball via direct contact. But unlike the first two, in the third example, there is no need to be in direct contact for the systems, for the objects which are in the force interaction. If you bring a magnet closer to an iron bar, we all know that that magnet will attract the iron bar to itself. So, from this aspect, from this perspective, we can classify forces into two. And in the first category, we name them as contact forces. Contact forces. And in the second category, we name them as field forces. And the difference is for contact forces, there should be a should be a direct contact. And in the field forces, no need to be in direct contact. So those two are the types of forces. Types of forces. Let's continue with the mass and how it will affect the motion of an object. Let's consider this guy who is trying to catch a ball which falls directly onto him. And in the first case, let's say this ball is just case one, this ball is just a basketball. Probably, most probably, he will be able to catch and stop the ball, right? What about the ball is made from, in the case 2, let's say the ball is made from steel. In case 2, the result may not be that pleasant. Our guy end up dead while trying to catch the steel ball. Let's consider another example. Let's say a ball is standing still on a ground, and there is a wind blowing over it. We can easily say that if the ball is plastic, let's say plastic, probably this wind will be able to move the ball easy. It will be easy for the wind to make the ball move. But if it was made from steel, probably it will keep its position, and it will be hard for the wind to move the ball. From those two examples, we can conclude that if the mass of an moving object is large, it will be hard to stop it. Similarly, if the mass of an object that is standing still is large, it will be hard to start it to move, or vice versa. So those are the effects of mass on the motion of an object which is under a certain force. By the way, in the first example, the force was created by the gravitational acceleration. So how we can quantify this concept? In his time, Newton conducted several experiments, and he showed that if you apply same force to two different objects which has different masses, the one with the smaller mass will accelerate greater than the one with the larger mass. So the larger the mass, harder to move. The smaller the mass, easier to move. As a result, you will achieve a greater acceleration with a smaller mass and a smaller acceleration with a larger mass if you apply the same force onto two different masses. So Newton was the one who quantified this phenomena. So from these observations of him, we can say mass and the acceleration are inversely proportional to each other. So let's talk about Newton's first law of motion. From those two previous examples we talked about, we can deduce this conclusion. In the absence of external forces, and when viewed from an inertial reference frame, I will explain this term, inertial frame, shortly. An object at rest remains at rest. An object in motion continues in motion with a constant velocity. In other words, if an object is standing still, and if there are no forces are acting on it, that object will keep its state. It will stay at rest. And if an object is in motion, and if there are no forces acting on that object, the object will continue its motion with a constant velocity. This is known as Newton's first law of motion. Okay, let's talk about inertial reference frames. To understand the inertial frames, let's take a look at those examples. In our example, we have a train which is moving with a constant velocity on the horizontal direction, and in that train we have a kid holding a ball in his hand, and we have an observer who is observing the motion of the ball. We also have another observer at the outside of the train, and that observer also observing the motion of the ball. When the kid releases the ball from his hand, the observer 1 sees the ball following a straight trajectory, but the observer 2 will see the ball following a curved trajectory like this one. The reason is the train was moving with a constant velocity when the kid drops the ball from his hand. Therefore, the observer at the outside of the train will see that the ball follows a curved trajectory. What if the train makes a sudden break? This time, because of the inertia of the ball tends to stay in its motion, tends to keep moving forward when the train breaks. Observer 1 will see that the ball is following a curved trajectory. What about observer 2? Observer 2 also sees that the ball is following a curved trajectory, but this time, since the train was moving, we know that train is decelerating because of the brake, but it still continues to go in the horizontal direction. Therefore, observer 2 will see a longer trajectory for the ball. Okay, let us add two more observers, observer 3 and 4. 3 is riding a bicycle, 4 was driving a car. 4 is driving a car. And let's assume that these graphs are representing their velocities with respect to time. The blue one representing the velocity of the observer 3, and the red one representing the velocity of observer 4. And let me add the velocity of the train on the graph, and let's assume that at this instant train starts to brake and kid releases the ball from his hand. So let's try to draw the trajectories seen by each observer. Of course, right now drawing the correct trajectories is impossible, but the purpose is here. I'm just trying to making a point. So let's just assume that These are the trajectories seen by those three observers. Let's say this one is seen by observer 4, and this one is seen by observer 3. Sorry, this one seen by observer 3, and this one seen by observer 2. You see, each one of the observers sees a different trajectory with different lengths. So when we ask to calculate the acceleration of the ball, just looking with these trajectories, each one of them will calculate different acceleration value because of their the length of their trajectories are different. So to eliminate this uncertainty, we need a reference frame, which is called inertial reference frame here, which has either a velocity of 0 or a constant velocity. In other words, to define a frame as an inertial reference frame, that frame has to be standing still or has to be moving with a constant velocity. So if we put those three observers on the same platform as the observer 2, if we take them here, they will draw the same trajectory. Right? So this is the definition of inertial reference frames, and here you saw that why do we need them. So in this video we have covered the basic understanding of force, types of forces, and mass, and Newton's first law of motion, and inertial reference frames. That's all for this video. See you in the next one.